I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. I am glad that in these tough times, many of you are learning from home. Here is a request from Ottawa. The need is to understand domain and range of functions. The course which the student is doing is MCR 3U for grade 11. I have divided this video in two parts. We'll discuss in part 1 some basics, get you ready for the test, and then we'll upgrade it to one more level since functions is also a topic of grade 12. So it's a good time to really understand it in details. So we'll talk about composite functions in part 2. So I hope that will really help. So take care, keep posting your request online every day. As you know, at 9 a.m. and at 9 p.m. I'm going to share with you some videos based on your request. So let's begin with domain and range. So in this video, we'll cover concepts of domain and range for functions, different forms to write domain and range, interval notation, and number line. They are very closely linked, and for many IB students, that could be a critical area. Then we'll talk about parent functions, their domain and range, and then transform functions. Now, once you understand the parent functions, it becomes very easy to write domain and range of functions using transformations. For ease, I'll share with you the graphs. Normally, you need to sketch the graph of transform functions and then write the domain and range. Rational functions have special importance since we'll talk about vertical asymptotes and horizontal asymptotes. And we'll also see how do we find domain and range of rational functions. Then I'll share with you some tricky test problems. Test will also be shared with you from the last 5 years, and then we'll get back to the summary. I hope you find this content useful. At the end of the video, do share your comments. That will help me to provide you better services. So let's continue with this. We'll begin with concepts of domain and range. Let me first share with you what is function itself. Now you have seen this term f of x, correct? Many students even don't understand what is this f of x. So let me begin with this term itself. Here x is the independent variable. And this independent variable gives you domain. So that is what we say all values. Gives you domain. Is that clear to you, right? And the term f of x totally, right? The whole term f of x is what is the dependent variable. So let me write this as dependent variable here. It's like y you use, right? So there's no harm in sharing with you the coordinate plane since we'll be doing most of the things on a coordinate plane, right? So normally x will be there on the x-axis and y will be there on the y-axis. So this y is what we call as f of x, roughly speaking. So we give it a name for each and every graph. So those are your y values and the dependent variables. Is that clear to you? Right? So dependent variables is values of f of x and they give you range. So what is the function? Okay, so now the question here is, what is the function? Right, that's the tricky part. Now treat this function as a box, right? So it is kind of a box which provides you with different operations. So we just say, let me make it a small thing here so that you understand. So within this box, some operations will be done, and that is the function f. And what we normally do is feed in some inputs. These inputs are x, and then we get an output, and the outputs are f of x. Is that clear to you? So now I hope things are absolutely clear. So when we are defining domain and range, we are actually looking for the possible values of x, which are the inputs to our function, right? And the range is the possible values of f of x, the outputs, right? And whatever is talked about is the function itself. This function could be a linear function, quadratic function, reciprocal function, sinusoidal function, logarithmic function, anything. You get an idea, right? So that's a very important concept to understand. And with that strong background, let's now look into different forms in which we could write domain and range. Now I've listed 4 forms here. The very first one is the list or the rooster form. Let us also see when to use this form, right? So as the name suggests, list, right? So you have to just list the domain and range. So normally, if I give you a mapping diagram, for example, let's say we have a mapping diagram here, and in which we'll write some elements in each group. Let's say the elements are 1, 2, 3, and so on. And here I'm writing letters A, B, and C, right? So we are now mapping them from 1 to A, 2 to B, 3 to C. For example, I'm taking a very simple example for you. Now let's write down the domain and range. Now since the arrow is in that direction, do you see that arrow? Arrow is going in this direction. Is that okay? So that clearly means that this is your independent variable. We'll treat this as the domain part, correct? Okay, let me erase this domain. Okay, so the domain is this portion, and the range is where you land up, the output, correct? So if I have to write domain, I will write only these 3 elements and list them. Does it make sense to you? And as far as the range is concerned, I will list A, B, C, the outputs, the mapping. You get the idea, right? So this is your list form. We also give it another name, rooster form, right? So many students in test paper, they see the form known as the rooster form. But basically it is listing out the elements of domain and range, right? So we have come across another critical word here, elements, which you learned earlier. Elements are, these are your elements. Do you see? Each and every individual is an element, right? So these are the elements which form the input, and the range is right there, okay? Now let's talk about the second form, which is the set builder form. Now when are you going to use the set builder form or set notation? Let's take another example here. Let's say, let me draw a parabola. Okay, so let's draw a parabola. Let us say the function here is y is equals to x squared, right? So these are the inputs to this. You can very clearly see that in that case, x can have all the real values. Do you see that? All the real values. So we can write here domain as within these curly brackets, x belongs to real numbers. Does it make sense to you? So that becomes a set form. In this particular case, if I have to write the range has restrictions. So within these curly brackets, I am saying y belongs to real numbers. However, so that is the condition, such that, or a condition is there, that y is greater than equal to 0. So this point is included, that is 0 for you. Do you see that? So that becomes your set notation. So how do you read it? Let me write down how you should be reading it. It really means y belongs to the set of real numbers such that y is greater than equal to 0, right? So I'm cutting it short here. So that is what it really means, okay? So I hope you've understood what is the set builder form. Now let's talk about interval notation. Where can we use this interval notation? So here is another very interesting example which can help you to understand how easy some difficult questions could be if we have to write them in intervals. So let's say we have a line here, right? And then we have some gap and we have another line here, for example, correct? So I'm making it quite simple for you. In the test, you could have such questions. So this point, let's say it is included. So when it is included, we put a solid circle, correct? Let's say this is also included for the time being. So let's say this point is -2. This is 0, of course, and this is, let's say, 3 for us, the y value. And it is going upwards. It doesn't look like, but let us assume that it is going upwards. That is your coordinate axis, x and y. So in this case, what is the domain? Well, the domain in this case could be written in set builder form, perfect. But what I'm going to use here is a simpler form, which I am calling interval notation, and see how easy it is. We are saying that the domain is all numbers, all real numbers, less than -2. That means on the left side of this, right? So basically everything on this side and everything on this side. So that becomes the domain for you. Is that clear to you? So I could write domain as from -infinity to -2. Now, infinity cannot be included. However, that solid circle included -2. Does make sense to you? In very short thing, we can write using interval notation our domain and range, and that will be the form which I'm going to use most of the time. Now for the other half, we have to include that also. So we write union, that is and, or, right? So union, or, and the other part here is we are including 0 and up to infinity. Infinity cannot be included. So that becomes the domain as a whole. So let me draw a line. I rushed into the range part. Okay, let's say this is the line. How about the range in this particular case? So I'd like you to pause the video, write down the range for this particular function using interval notation. Well, clearly, as far as the graph goes, we have to see from left to right. And what you notice here, it goes from -infinity to this point, and let's say this point is 1 for us, okay? So in this case, the range will be from -infinity to 1. Perfect, 1 is included. Union after 3, right? So it is including 3 to infinity. Is that clear to you, right? So that becomes the range for this particular set. Perfect. So that is how we could write domain and range. Now, number line. So let me take a number line on the top side of this page. So I'll use, let's use this color, number line. So let's say this is our number line. And on a number line, I will only represent the domain. So let me represent domain of the given function, which is the third one here. So we'll write domain of this function on a number line. So on a number line, we'll have, of course, somewhere 0. So let's say this is the 0 for us, okay? And we are saying everything to the left of -2. So we could actually mark this as from -2 onwards like this. Do you see that? And then from 0 onwards. So that very clearly indicates on a number line your domain. So this point here is -2 and that point is 0. So on a number line you can show, as I have shown, domain of a function. Does make sense to you? So with this in mind, just go through this. I think we have covered the basic concepts. So now let's jump into some more details about interval notation and number line. I think it's an important thing to discuss at present so that you could relate the two. Now when we say interval notation, as you've seen last time, we did mention something like -infinity to -2. Now that really means that on a number line we have the domain, which could be represented as, let's say this is our 0, from -2 to -infinity, and this time I have put a bracket which is not a closed bracket, so it will be an open hole and then, so that is -2. So note we have an open hole here, or you can say open circle. So that means not included. Now, this is very important, and therefore I kind of introduced it in between. So let me take another example. We could have something like this from -3 to, let's say, 5, and we include both of them. Then in that case, on a number line, how are you going to represent it? Well, clearly, let's say this is our 0. We're talking about the 2 points which are -3 and 5. Perfect. We're interested in everything in between them, including them. So we'll make circles here and we'll fill them in. When you fill them, they get included in your domain. Correct? So now these are filled in circles. That means included. Does make sense to you? Perfect. So that is very important, and filled in also means these square brackets, right? And open brackets means open brackets, like that, parenthesis. Does make sense to you, right? So let's take another example, and this time we will do something like this. -3 to -1, we are including 1, union, and we are saying from 1 to 4, not including 1 but including 4. I would like you to pause the video and represent this on a number line. Right, so I'm just taking my time, giving you time to represent this on a number line. So I hope you got it. If not, let me know. You can write comments as we move along. So -3 is, let's say this is -3 for us, this is -1 for us, that is 1, and this is 4. What we are saying here is that -3 is not included, so I'll make an open circle. -1 is included, so I'll close this circle. Fill it up. 1 is not included and 4 is included, so we'll fill it up. Everything in between -3 and -1, everything in between 1 and 4. That is how you are going to represent this. So I hope That is absolutely clear. Perfect. Now with that, let's move on and take up some examples. So now we'll take up the parent functions and how to work with parent functions. We'll begin with simple parent functions line, so which is called the linear function, right? So this is your linear function, and that is quadratic. I like you to write domain and range for these functions. So clearly, in short form, I am writing domain as dx. X represents the x-axis here, and y will represent the y-axis. Is that clear to you? Now, there are no restrictions, so we say x belongs to real numbers, and as far as the range is concerned, the y values, they also belong to the real numbers. Can you tell me the form which I have used here? You can go back, refer to our discussion, and try to get the names right. In case of a parabola, which is a graph of a quadratic function, there is no restriction on the domain. It could be any value. However, the range is restricted. As you can clearly see, the y values do belong to real numbers, but they should be always greater than or equal to 0. So when you do square of a number, it is always positive. Perfect. Let's move on to reciprocal functions, and this is the square root function. So let's remember the name. This is called reciprocal function, right? And that is the square root. All our functions we're talking about. And now write down the domain and range for these functions. Perfect. Write down the domain and range, and then check with my solution. That's the whole idea. Learn as we are doing. It is really very simple now, right? So here I will use a different notation. You have to name the notation, right? You can see here that the graph is kind of like this. I could write this as from minus infinity to 0, right? I could write this as minus infinity to 0, and both are not included, union, and here we see from 0 to infinity. Is that right? So we have used the interval notation to describe it. Now let's write about the range of this function. Well, if I have to write the same thing in the range but set builder form, so I'm mixing it up. You should not be doing it, but I'm mixing. So mixed form, not recommended. Is that clear to you? But I'm doing it just for explanation. Okay, you don't do it. You have to use the same form both places. So if I have to represent the range, which is the y values, we do see that y belongs to the real numbers. However, y is never equal to 0. So that is how you could write in set builder form, or the set notation. Is that clear to you? Perfect. So that is how you have to work. So domain for this is x belongs to real numbers where x is greater than or equal to 0. The value of 0 is included. As far as the range is concerned, that also belongs to real numbers, and y is also greater than or equal to 0. Perfect. The next example here is of two functions which are absolute function and sinusoidal function, right? So it is absolute function and this is sinusoidal. Take your time to write down the answers, pause my video, and then match the solutions, correct? That will help as we go along. So let me write down the range and domain for these functions. Normally we write domain first. So we say x belongs to real numbers, no problems. There is no restriction for both these functions. That is a similarity. So many times we are asked similarities and differences. But a huge difference here is that y belongs to real numbers where y is greater than equal to 0. And in this case, y does belong to real numbers. However, y is between -1 to +1. So the sinusoidal functions are restricted in range, as you can very clearly see. That is the -1 +1 restriction. Clear? Let's take the next example. This is actually a test question for you. Now in the test, you'll be amazed. You're asked all of a sudden some points. Did we learn how to write domain and range of just few points? I don't think so. Now you have to be innovative and you have to write domain and range of this function. Okay, so figure it out and then match with my solution. This is what you're going to see in real test paper, the very first question. It is always question 1, right? And always a very difficult question to answer. How will you write domain and range for this function? Well, the best form is to list your items or the elements. So first element here is -2. We did learn it, right? And then we have -1 and we have 0, 1 and 2. So you see the rooster form or the list form helps, and that is how you should be writing domain and range for these functions. Now this value is at -1, this value is at 0, the y values we're talking about, and it is better to write it in order. So I'll write 1 first and then 2. However, you should not repeat the values, right? So the caution here is do not repeat. Values. So I do see that there are twice we have these zeros here, right? You should not write 2 zeros. There is no point. It is considered not good or incorrect at times. Does make sense to you, right? Now here, this is kind of very tricky. We have a gap in between. Do you see that? So I will rather, so I'll use this as a whole. It's not mentioned, but I'll use this as a solid point, this as a solid point, and this as a whole to write my restrictions. Okay, just to make it more complicated. So I can say that the domain here is from this place to this place and then from here to there. And therefore, I can write domain here is not including -2 to 0, including it, union, and then we're including value of 1 but not including 2. Does it make sense to you? So that's very typical of a test paper. This is what you will see, not a simple parent function. Does it make sense to you? Now let's move on, and now we're looking into some more tricky parts. So that becomes a real test question for you to do. It's a piecewise function, correct? We have different pieces, and of course, when we have different pieces, the best notation to use is the interval notation. Clearly, I have given you solid marks here. Solid means included, right? Solid means included. So how are you going to write the domain for this function? So write the domain and then check with my solution for both these. These are actually your test questions. Okay, you can actually write them in comments. So put them in comments. Okay, take your time to do this. Let me just share with you other test questions now. So then we have a test question here, which is a square root function. Now in square root functions, what we need to do is, let's write it down in a different ink. So we have square root function. Normally, they will not give you the graph. You need to sketch the graph. Now, since it is the very first lecture on domain and range for you, I would like you to look at the graph. Think like this. This point is included and there is an arrow here. That means it continues to move in that direction. Here is an arrow and that is a starting point. Now with that in mind, I would like you to write down the domain and range. Does make sense to you? Now the last page here is on the test practice. So we have some equations here to work with, and these equations are very typical and kind of difficult at times. So I'd like you to actually pause the video, answer these questions. Now we do have two examples here where we have restricted the domain, and then for that restricted domain we are asking for range. So think about it and then do it. Is that clear to you? Now we're going to take part 2 where we are going to discuss the solutions of these questions. Till then, take this as an assignment, right? So in part 2 we'll discuss solutions of questions, plus we'll learn about combination and composition of functions with more test practice. That is the best way of learning domain and range. So I hope you really enjoy it. It is a very concise video where in 30 minutes I'm able to teach you the concepts which takes a month for students normally to get across. If you really do this exercise, I can guarantee that you will get more than 90% marks in any test on domain and range. I hope that makes sense. So look forward to my part 2, which I am going to post tomorrow. So have a good look at it, submit your assignment, and share with me the difficulties you are facing. Those will be solved and taken care of in part 2 if you are in a position to share with me. I hope that makes sense. So once again, a quick reminder of tough times. I'm here to support you from home. Everything is absolutely free, absolutely free. I'm giving you this free time so that you can actually excel when the schools reopen. We have a website, and our website is under construction. The work going on is not that fast, not as good as I have been expecting, mainly because we are lacking funds. So in case you're willing to donate something, you can always donate on our website. It is still under construction, so all the donations, I hope the module will be running after the next week. So the things are on hold since I need some support. Doesn't matter. But on YouTube, we'll continue giving you support as ever. I hope you enjoyed. Provide your feedback and more questions. Thank you and all the best.